Hi, today we'll continue to talk about 7.8. As we saw from last time, we have covered all the necessary theorem that we have to do. And today I will give you an example about the comparison theorem. Let's use an example of comparison theorem. Okay, so what is a comparison theorem? So what is the comparison theorem? Comparison theorem is that when you have gx and fx, and let's assume that gx is less than fx. So the theorem states that if gx is divergent, then fx will be divergent. And if fx is converged, gx will also be converged. You can see how I illustrate this on the last lecture, last review session, which is I upload online on Blackboard. You can follow on the link, but that is somewhat the material. So let's take a look at one example specifically. So question. Okay, so finding the integral, finding like whether it is converged or diverged of 49 times 2 plus e to the minus x over x dx. Okay, so how are you gonna solve this one? So you luckily have that e to the power of minus x. So because e is like a positive number, so e to the power of x is minus x is always larger than 0. So e to the power of minus x is always larger than 0. Because this is e is like a positive number, so you don't have to worry about that. So because e to the power of x or minus x is always larger than 0, which means the whole equation, the whole function here is larger than 49.2 over x, right? Which will equal to 98 over x. Let me just erase it right here. So because this one is larger than 98 over x, so now we only have to concern about 98 over x. So you have 1 to the infinity, 1 to infinity of 1 minus x is converged, right? Oh, it's diverged. So because it is diverse, so based on the comparison theorem, as you see on the previous page, the larger one, if the so 98 over like 98 times this one will also diverge, and because the smaller one is diverged. So it leads to the fact that the larger one will also be diverged. So which means the whole equation right here, sorry, is diverged. So you have just solved the problem within just 2 steps. And look how complex the equation at first is. And look how complex it is. And then you change it to here. It becomes much, much more easier for you to solve it. So that's one example of comparison theorem. Let's take a look at another one. Wow, this one is interesting. Okay, so it states that another one is from 0 to infinity of arctangent of x over 2 plus e to the power of x dx. Okay, so how are we gonna solve this one? So at first you're gonna have to decide like how to compare this thing. So you know that arctangent of x is always smaller than pi over 2. So because that's the range of arctangent x, right? So pi over 2 is like 3.514 over 2. So that means like 1.5, like around that. And you see that you have a 2 in the denominator. So if you can choose something that can simplify the equation, that would be the best, right? So this one is actually smaller than 2. So you can easily see that this one, the original equation, will lead to some smaller kind of thing. So you can guess that you will have to solve the one that is larger, and the larger one will be converged. And if the larger one is converged, the smaller one will be converged. Because in the comparison theorem, there's like only 2 possibilities. So if your equation is smaller than something, it's pretty sure that it will be converged. Like that should be obvious. So like you can take a guess or something. So and that should be easier. So you have 2 over 2 to the power of x, right? E to the power of x. So what are we going to do next? How are we going to do next is try to simplify the simplified equation. So like you have to simplify it until it become a form that you absolutely know if it is converged or diverged. So this one actually smaller than 2 to the e the power of x. Why? Because if the denominator is larger, then the whole equation is smaller. So this one is 2 to the 2 times e to the power e minus x, e to the power minus x. So, okay, so now we have to solve 1 to infinity of 2 to the e to the minus x. So, if we know in advance that we have to solve this one and prove that it is converged. So, you have learned how to solve the integer, like the improper integral, right? So it will be t to the infinity of 1 to the t of 2 to e to the power x dx, right? So it will be limit to t to the infinity of, sorry, ah, so integrating this one will be like minus 2 to e to the minus x, 1 to t, sorry. So sorry for the bad writing, like the board is extremely hard to use. And it will be interesting. Minus 2 over t plus 2e. Oh, sorry, the integration comes from 0. So this one will be 0 and 0, 0. Now, this one is not 0. E to the minus 6 is 2, e to the 0 is 1, so this one is 2, so it will be plus 2. The limit t to infinity. Okay, so when t become infinity, e to the power minus t will become 0. So it will become 2. So 2 is not 0, it's not infinity, so the limit does exist. So if the limit exists, which means the original equation right here is converged. If the equation right here is converged, which means the messy, complex original equation is also converged. So that's the comparison theorem. I really hope you guys show up because I will contain a lot of things like, and exam 2 is normally the hardest one. So if you guys can come, that will be the best. Okay, see you next time.